Good day everyone. Today we will go beyond basic definitions and explain how electricity actually behaves in circuits and how this concept apply to real life systems. Okay, let's go! By the end of this presentation, you should not only be able to solve circuit problems but also understand why circuits behave the way they do and how they are used in real life. First, we're gonna explain how resistance affect current, analyze series and parallel circuits, also applying Ohm's law, and solve real-world problems. We're also gonna evaluate efficiency and safety. So first, what is resistance? Resistance is the opposition to the flow of electric current. It occurs because electrons collide with atoms inside a material. The more collisions that happen, the harder it is for the current to flow, and some energy is lost as heat. In simple terms, it is like traffic. When the road is crowded, movement becomes slower. In the same way, electrons move slowly when there are more obstacles inside the material. This is why some materials like copper have low resistance and are good conductors, while others like rubber have very high resistance and act as insulators. Next, resistance depends on three main factors. First, the length of the wire. Next, its thickness. Then lastly, the type of material. A longer wire increases resistance, while a thicker wire decreases it. Different materials also affect how easily electrons can move. For example, a long and thin wire makes it harder for current to flow compared to a short and thick wire. Temperature can also affect resistance. As temperature increases, atoms vibrate more, causing more collisions, which increases resistance. This is why wires heat up when used for a long time. Now let's move on to Ohm's law. Ohm's law shows the relationship between voltage, current, and resistance. Voltage is the push, current is the flow, and resistance is the opposition. If resistance increases, current decreases, assuming voltage stays the same. We can think of voltage as a pressure like a water in a pipe. The higher the pressure, the stronger the flow. But the pipe is narrow, which represents resistance, the flow becomes weaker. This relationship is very important because it allows us to predict how a circuit will behave. Engineers use Ohm's law to design safe and efficient electrical systems. In a series circuit, there is only one path for current to flow. This means the same current passes through all the components in the circuit. Because there is only one path, all parts are connected end to end. One important characteristic of a series circuit is that if one component fails or removed, the entire circuit stops working. This is because the path of the current is broken. For example, in older Christmas lights, if one bulb stops working, the whole set turns off. This shows how dependent each component is in a series circuit. Series circuits are simple and easy to analyze, but they are not commonly used in systems that require reliability. In series circuit, total resistance is the sum of all individuals' resistances. This means adding more resistors increases the total resistance, which reduces the current flowing in the circuit. Next is the parallel circuit. In a parallel circuit, there are multiple paths for current to flow. Each branch provides a separate path, so the current is divided among them. One key feature of the parallel circuit is that the voltage across each branch is the same. However, the current can vary depending on the resistance on each branch. Unlike series circuit, if one branch fails, the rest of the circuit can still function. This makes a parallel circuit more reliable and practical for real-life applications. A good example is the household wiring, where appliances are connected in parallel so they can operate independently without affecting each other. In parallel resistance, total resistance decreases as more branches are added. This is because additional paths makes it easier for current to flow through the circuit. Instead of all current passing through one path, it is distributed across multiple paths, reducing the overall opposition. This is why adding devices in parallel does not necessarily reduce performance, as each branch allows current to flow more freely. However, it can increase the total current drawn from the source. Understanding this concept is important when designing circuits to ensure they can handle the required current safely. To compare series and parallel, series circuits have one path and are less reliable because one failure stops everything. Now, in parallel circuits have multiple paths, making them more reliable and commonly used in real-life systems. In series circuits, all components share the same current but the voltage is divided among them. In contrast, in parallel circuits, the voltage is the same across each branch, but the current is divided. Because of these differences, each type of circuit has its own advantages and disadvantages depending on the situation. Engineers choose between series and parallel designs based on the needs of the system, such as safety, reliability, and efficiency. Now, to understand their applications in real life, like I've said earlier, series circuits were used in older Christmas lights, where one broken bulb could stop the entire set. This shows how single failure can affect the whole system. Now, in contrast, for parallel circuits, household wiring uses parallel circuits so that appliances can work independently. For example, turning one of appliance does not affect the other appliances. Parallel circuits are also used in modern buildings, electronics, and power distribution systems because they are more flexible and reliable. These real-life applications show how understanding circuit design is important in everyday life and technology. Now, since we talked about the basic concepts and the formulas to use, we're gonna move on to the problem solvings. Now let's move on to our first problem. Here, Maria is setting up 3 decorative lights in a straight line for a school event. Each light has a resistance of 4, 6, and 2 ohms. It is all connected in series to a 12-volt battery. Now Maria is trying to find the total resistance of the circuit and the current flowing through the lights. Now, to solve this problem, we first add all the resistances. So, 4 plus 2 plus 6 is equals to 12 ohms. Then, we apply the Ohm's law. So, it's the current equals the voltage over resistance. So, we divide 12 over 12 equals 1 ampere. This shows that the higher resistance limits the current. So for our next problem, it says that John is wiring 2 electric fans in his room so they can work at the same time. The fans have resistances of 6 and 3 ohms, and all of them are connected in parallel to a 12 volts power source. Now John is trying to find the total resistance and the total current drawn from the source. To solve this problem, we're gonna use the parallel resistance formula, which is 1 over R total. And then to apply this, we're going to substitute all the values. After substituting them, we're going to add 1 over 6 plus 1 over 3. Then simplify, we're gonna get 3 over 6. To get the R total, we're going to reciprocal 3 over 6, which becomes 6 over 3. then it equals to 2 ohms. And next question, we're gonna find the current using Ohm's law. Now we're gonna divide 12 by 2, which equals 6 amperes. Notice how the current increases when resistance decreases. Now for our third problem, it says here that Anna is designing a simple circuit project. She connects a 5 ohm resistor in series with 2 resistors of 10 ohms and another 10 ohms arranged in parallel. It is powered by a 10 volts battery, and Anna is trying to determine the total resistance of the circuit and the total current flowing in the circuit. First, we're gonna solve the parallel part. So here, we're gonna use the formula 1 over R total, which means it's gonna be 1 over 10 plus another 1 over 10. And add them both, we're gonna have 2 over 10. And then, after getting the sum, we're gonna reciprocal it, which becomes 5 ohms. Now for the series part, we have a 5 ohms resistor in series, and then we're gonna add it to the R total we get from the parallel. So 5 plus 5 is equal to 10 ohms. Next, we're gonna get the total current flowing in the circuit. So we're gonna apply the Ohm's law. Here, we're gonna do 10 divided by 10 equals 1 ampere. This shows how complex circuits can be solved step by step using the formulas. In here, we're gonna talk about the power and energy. Power is the rate at which electrical energy is used or transferred. It is calculated using the formula P equals V times I, where P is the power, V is the voltage, and I is the current. This means that when either voltage or current increases, the power also increases. In real-life systems, higher power usually means more energy is being consumed. For example, appliances like electric heaters and ovens use high power because they convert electrical energy into heat. It is also important to manage properly to avoid overheating and energy waste and potential damage to electrical devices. So, the common misconceptions in series and parallel circuits is that the current gets used up as it flows through a circuit. But in reality, current continues to flow while it is the electrical energy that being used by the components. Another misconception is that the parallel circuits are always better than series circuits. While parallel circuits are more reliable, series circuits are still useful in certain situations, especially when simplicity is needed. Some people also think that the higher voltage is always dangerous, but safety actually depends on how voltage, current, and resistance interact. Understanding these misconceptions help us build a clearer and a more accurate understanding of how electrical circuits really work. Now, these questions encourage us to think deeper about the circuit's work. For example, why are homes wired in parallel? What happens when resistance becomes very high? And how engineers can reduce energy loss in systems. To summarize, resistance controls how current flows in a circuit, and different factors like length, thickness, and material affect it. We also learned that circuit design plays an important role in how electricity behaves. Series circuits have a single path and are simple but less reliable, while parallel circuits have a multiple paths and are more commonly used in real-life systems. By applying concepts like Ohm's law, we can better understand and predict how circuits work. Overall, understanding these principles helps improve safety, efficiency, and the proper use of electrical systems in our daily life. So thank you for listening. I hope this presentation helped you better understand how electricity flows in a circuit and how this concept affect us in real life situations. Thank you. Goodbye.